In this video, we'll look at the two hypothesis tests that the Data Analysis Toolkit offers for discrete data, a two proportions test and chi-squared. Previously, we looked at Pareto analysis for problems that had been experienced by a financial institution for a number of different types of transactions and customer accounts. We did a Pareto analysis and we saw that the new account setup was the most problematic type of transaction, and we were able to dig further into that and see that it seemed to be mostly associated with self-employed or retail accounts. But there's a problem with that. It might simply be that there are a greater volume of new accounts being set up for these rather than students, for example. So we need hypothesis testing to see whether what we've got actually constitutes proof that there's a difference in the proportions. I'm going to start with this one, a two proportions test, which is specific to situations where you want to compare two proportions, as the name implies. And I've already typed the data in. The data goes straight into this block here. And what you need for the two examples is the two different categories, then the number of events, which is the generic term that's used, but in this case we're talking about transactions that have failed, and the number of trials, again that's a generic term, it just simply means the number of cases that you've got in total. So we had 15,324 transactions here, and 19 of those resulted in a problem, and that gave us a proportion of 0.00594, so about 0.5%. And similarly for the student cases, it also was very similar to 0.5%. In this case, we were not able to prove there was a difference, unsurprisingly, with a p-value of 0.9. That's a nice simple test to be able to run. The other type of test we can offer is a chi-squared test, and this is used whenever you have more than two categories that you need to compare. So we have here self-employed, retail and student. These are the numbers that came from the Pareto chart. 92 problems for self-employed, 91 retail, 36 student. What you didn't see in the Pareto chart was the number of transactions that were processed perfectly okay, and there they are in each case. So the chi-squared analysis will look at the proportion of defects relative to what you would expect if they were actually all the same proportion. And that leads you to a p-value, as usual, which in this case is 0. So yeah, you've definitely proved that proportions are different. We can go further than that, and we can say we need to look at these chi-squared numbers here. A chi-squared number is a measure of how unusual a particular result is in the context of the other results. And what you're looking for is the biggest one, which is here. 19.9, by far the biggest chi-squared value, which means that the number of errors in the self-employed category is unusual relative to what you expected it to be. We had 92 errors, and we would expect 58 if the error rate was truly the same between all three account types. So now we have statistically proved that there's a problem specifically with the self-employed accounts being set up. That's the last video we'll use covering the graphs and statistical analysis worksheet. In the remaining videos, we'll look at these other sheets.